Hi and welcome to this week 1 review for RMIT Industrial Design Flexible Modelling course. If you're not a part of the course, welcome to the video, and we hope that everyone takes something away from this. So without further ado, let's get modelling. Probably the first thing that I'd like to say is that I think that you have to have a 3-button mouse. 3-button mouse is critical to successful modelling in 3D, be it with Rhino, Alias, Fusion 360, SolidWorks, whatever program. You really need a 3-button mouse. This is a very cheap Logitech version that's Bluetooth, so I don't need any dongles or any adapters. Runs off a AA battery forever. It's a fantastic little mouse. Highly recommend that you get one. You might be noticing that my screen moves really quickly and pans around very effectively. And that's because I've got a 3D connection space mouse. And the space mouse gives me a lot of control, and it lets me move my objects around very quickly, pan, zoom, rotate. It's a fantastic tool. Probably a bit pricey, but I love it. Okay, without any further ado, for the second time, let's get going. First of all, I think it's really important to understand that Rhino, when you open it up, it's got these 4 viewports. It's got a top viewport, it's got a front viewport, a right viewport, and a perspective viewport. And it's well worth considering that if you've designed something, you've gone through a whole range of sketches and iterations, and then you've designed that final thing that you want to start making, go and draw some fairly tight and well resolved top, front and right or side view images, and you can import them as a plane, and you can scale them up to fit the right dimensions. You can draw a line on the screen that's the right width, the right height, and you can get your images scaled properly. And then you can model around that. You can use it as a base underlay. I highly recommend that you do that. So we're just going to go through a very quick intro. So Rhino has toolbars across the top. Over here, like we've got surface, a whole bunch of pull downs. We've got solid modeling, sub-D modeling, mesh modeling, transformation tools, a whole range of other tools that can edit things, analysis tools, rendering, a whole bunch of different things here that you can access. It also has tabs here above the modeling screen, and we can click on those tabs. We can look at construction planes, where we actually build our geometry, and we can move construction planes around. We can set different views. We can set up our display, our selections, our viewport layout, which we'll talk about in a minute. And most importantly, I think here is the curve tools and also the surface tools. And we'll be using the curve tool, and I like to click here. I've got all my layout of all my different curve tools here. I can click on surface tools, and I've got all my layout of my surface tools. And we'll note that the first 6 icons are the same for the curve tools and for the surface tools. And they are the basic, selection, where you can come in and select something, the moving, trimming, splitting, joining, and exploding, or undoing the joining of different surfaces or curves. We can explode them apart into their subparts. Okay, the other important thing to look at, and what I'll do is I'll just set up the viewport layout, and you'll note that there's this icon here which is called synchronize views, and it also has a right button function on your mouse which is called toggle linked views, and this is a fantastic tool. I turn it on and I use it all the time. So to explain that, you can see here in the top view, or even down here in the front view, I can zoom in, but my other viewports haven't zoomed to match. I can left click on synchronize viewports and it will synchronize to the one that I have active. So the front viewport's currently active. You can see it here in blue, it's active. If I left click on that, all of these have now matched the same scale. But if I click in the top viewport and I move my mouse, you'll note that the others didn't match up with it. So if we right click and toggle linked, now you'll note that when I zoom in and out that they're actually linking, so I can get my scale. My scale is staying the same in all the viewports. It's a really great little function, little tip and trick. The other nice thing that you can do is that if you press the middle mouse button, you'll note, and here I've got a few more icons than you'll have in a standard setup, is that you've got the quick shortcut to commands that you might use a lot. And the way that you can edit that is just press the middle mouse button, grab this thin grey bar at the top and move it around and let go, and you'll see it expand. And then what we can do is we can come in here and let's say, I don't know, choose toolbar of some kind. Let's just click out here. Yeah, let's grab, that's something I don't have. Curviture graph. Let's grab the curvature graph. So what you have to do is you have to hold down, I think it's Control, and then note that the text, it says copy link. Hold Control down, left mouse button, and drag it in. You can actually see I've already got it here. Drag it in and then let go. I'm just gonna not do it, and it'll copy it in here. Okay. Then you can press the red X, and whenever you press the middle mouse button, all that will appear. Don't forget to shut down Rhino and reopen it again for that to be locked in place. If your computer crashes for some reason, you'll lose that. So just close Rhino and reopen it again. Okay, so we've got our main toolbars, and we can see that when we select, say, curve tools, that we get the main toolbars for curves. And at the top we get all the edit tools here, like fillet, chamfer, fillet corners, they're a useful tool. Adjustable curve blend, exceptionally useful tool to get beautiful flowing surfaces and curves for surfaces. Arc blend, matching curves, matching one to another and matching them up and getting them to flow properly. Here we can toggle our control points on and off. And we can rebuild curves here as well, rebuild. And typically I just type rebuild on the keyboard. And what you'll notice up here is the command line. So whenever we press on one of these icons, or whenever we type something like rebuild or line or curve, circle, you'll note that the command line asks you questions. Now in Rhino you need to keep referring back to the command line. It's really critical that you keep looking at the command line. If you don't, you'll be wondering why something's not working, this program's crazy, it's not functioning properly. It's probably because the command line's asking you to do something, and then you've moved on and you're trying to do something else and you didn't realize. So just press escape in the keyboard and it will reset the command line to being clear like it is at the moment. There's nothing written in there, so there we go. Line, press enter. Now it wants the start of a line, so we can click that and we can draw it. Now you note the command line is empty. Let's select that, just delete it. Okay, what I want to talk about, I'm actually going to delete. Actually no, I won't delete them. I'm going to talk about the layers. Come over here to the layers. And what I'm going to do is I'm going to create a new layer. So I'm just going to right click in this white space and say new layer. And I'm going to call it surface demo. Okay. And I'm going to select everything that's here. There's a couple of curves in underneath the bottom there. I'm going to move them to the surface demo layer because at the moment they're in the default layer and you can see the default layer is selected. So I'm just going to right click on the surface demo and I'm going to say change object layer, and that will move everything to that layer. We could copy it if we want, so if we're doing things and we aren't sure what's going to be destructive in our modeling, then we can copy to another layer, try it out, see if it works. If it works, continue going from there. I'm just going to change object layer. And then if I press on this little light icon, I'm going to click it off and you'll note that everything has disappeared. But I'm still on the default layer. I can't stress enough how critical it is to name these layers. Give them names: curve, construction curve, master curves. They all mean different things. Surface, construction surfaces. You might have the master final surfaces. You might have manufacturing surfaces. You might have a range of different options, concept 1, concept 2. And you can hide and move all of these geometries onto those different layers. Unlike, say, Fusion 360 or SolidWorks, in Rhino, we can have a number of concepts. We could be modeling a computer mouse, and we can have 5 computer mice all on the screen at the same time. We can rotate them around, and we can edit them and work on them by just using the layers. Where if we did that in Fusion, we would have to create an assembly and drag all these different files in and make copies of them. Where in here we can just work directly onto the model. Okay, so we've talked about layers. Let's talk about the grid. So the grid is here. Let's go back to, is it display? We've got viewports. Here we've got grid display on and off. We can turn the grid display on and off in our model, but we might want to look at the grid properties. Now I'm trying to remember where that was. It's so feature rich. Let's just go back to standard and let's look at, no, I'm not going to find it now. Let's look at settings. Yeah, settings. So this settings icon here. Let's press that. And in the settings, we can see that there's a whole range of different things that we can edit. And one of them is options. And I'm pretty sure under options, so settings, options, we've got grid. That's where it is. You'll note that in all viewports, our grid, so this grid here, the whole grid, is 200 in the positive direction and 200 in the negative direction, in all directions, in X and Y. And the minor grid line spacing is 1 millimeter, and the major grid line, this darker line, is 10 millimeters. Now you can change this depending on what you're wanting to do, but I find that starting out modeling and grid snapping to 1 millimeter works really well to get your product up and running. You can turn the grid snap off and refine things, but I like to have the grid snapping set up this way. So I'm just going to go OK. So that explains the grid, and you can make the grid bigger or smaller. It doesn't really matter. You can model beyond the grid. You don't have to be constrained to the grid. Okay, so we can see down here we've got our X, Y, and Z, and that's when we move our mouse around into the positive. This is our world 0, 0, 0 in here. This is our 0, 0, 0. And we go positive in the Y, positive in the X, and then positive in the Z. And we can see that readout here when I'm moving my mouse around. We can see we're working in millimeters, and I've got my grid snapping turned on. So if I do something like if I type line in the keyboard and press spacebar, start of line, I could start the start of that line at the 0, 0, 0 and then pull it out. And you'll note that it actually showed us something. So if I click that and move, there's the length of my line. Down here, it's showing me the length of my line. So you've got to look around a little bit and observe what the screen's doing. Observe the command line, observe some of the units and dimensions that you're working on, observe your underlying sketch, looking in perspective, looking in top, side, right, the front, all that kind of stuff. Okay. We've also got Osnap. So if I again draw a line and I press spacebar to bring back the last command, so it was drawing lines, you'll note here that because I've got my end spacing turned on, if I click this, whoops, if I click this and I go Osnap off, go to draw a line, you'll note that it doesn't try to lock onto anything. But if I turn my Osnap on, then it wants to go to the end point or to the knot. And that's because of what I've got selected over here. I could go to near, draw that line off. Press it, I could go to intersection. So you see it says end intersection knot and draw a line off from there. And we can start connecting our lines. So if we get a control point curve, we could start it from the end and then draw it out and move it around like that. But note that this actually isn't tangential. So it's important to note that this line here, the control point, when we move it, then nothing's tangential. And we'll discuss some of these things later on when we're working. Alright, so we talked about this and the object snapping, we talked about grid snapping, the GumBall. You can see the GumBall here. The GumBall is the most useful tool ever. The GumBall allows you to manipulate, like grab a control point, come over into another viewport, move that control point, start to get some three-dimensional aspects of your curve happening. So we can move, we can grab that line, we can grab that control point, we can move it up and down in the right view. We could move it, you know, left and right in the front view. We could adjust it in the top view. Okay, and then if we select it and right click, you know, I've got my curvature comb here, so I can actually see how my curve is moving, and I can analyze my curve, and I could grab this control point and line it up so that it's vertical, which it's not at the moment. There it is, it's vertical now, and now I've got a perfect tangential connection between anything that runs down here and this curve. I'm just going to turn that off. Okay, so let's go back to the curve tools, and you know, we've got our control point curve. We can click out a degree 3 control point curve. We've got our line, polyline curve, and we can click out some polylines like that. Let's maximize this viewport. Let's move this one over here a little bit more. Let's get rid of all of this stuff. And let's make a circle as well. So let's just hold down shift so that we make our circle vertical, the end line. When we select a circle, let's make a copy of it. So to copy it, grab the GumBall, and notice here it says copy, tap Alt. So hold the Alt key and pull it, and now we go to copy. We hover above the GumBall. Different parts of the GumBall will do different things, okay? So what we're going to look at here is that if I edit this control point, if I pull it out, note that a circle is made up of 4 arcs. It's actually not a perfect spline. This is really important to note. And that's because it's a degree 2 curve. Straight line is a degree 1 curve. And here we've got our control point curve, and it's a degree 3 by default. And you can actually see the control point lines. That's the degree 1 curve, and that's what we're manipulating. And then we're averaging out a curve between those points at degree 3. So what we can do is we can rebuild geometries. I'm just going to do Control Z to get that back. And we can rebuild this curve. So let's go up here to the rebuild icon. And you can see here that the original point count was 8. And it actually is 1, 2, 3, 4, 5, 6, 7, 8. And the rebuild is 8. But instead of being degree 2, it's degree 3. And we can see the 8 points running around here. Now let's go OK. And then let's go into our perspective view. Let's delete this geometry here. So let's grab a control point here and let's move it up and we get that arc. Let's grab, oh, I've got multiple curves in here. That's the old geometry that I didn't delete. So let's press delete on that. Let's select this. Let's grab that control point. Let's pull it up. And note now it's a beautiful smooth transition. That's because it's been rebuilt and it's now a degree 3 with 8 points. So if we rebuild this line here, let's go up to rebuild. Note that it's point count 6, it's gone to point count 8. We could make it 6 or say 7, put it to degree 1, series of straight lines. Let's put it to degree 2, a series of smooth blended arcs that fit together. Put it on degree 3. We could use degree 4 or even degree 5, depending. Typically not, we use degree 3. And I would believe that in the automotive industry, degree 4 is the curve that they use most. We should ask our learner colleague Paul. Once we're happy with that, we can press the delete input and that will stop it from making a copy. But if you want to keep the old geometry, don't have delete input on and just click OK. And there is that line, or that curve actually. And we can edit the curve by editing these points and manipulating our curve. If we want another control point along this curve, if we want another control point in here, we have to rebuild it and take it from rebuild degree. Rebuild, let's go rebuild. Because I actually can't remember what it was. I can't type rebuild. Let's just click on the icon. It's degree 7. Let's make it rebuild point count 8. And go OK. You'll note that we didn't delete the old one. So there's the old one there. Delete that. And there is a degree 8. So it's added in some extra control points. So there's how we can rebuild curves and we can adjust their degree from 1 to 4, typically to 3, and how we can control geometry to get the desired effect that we're after. I'm just going to delete all this. The last thing I want to talk about here is like drawing rectangles. So let's just go back to our top view. And I'm going to draw out a rectangle. And let's make the rectangle here, what is it? It's 50 by 30. Let's grab it and let's just move it. I don't know, an arbitrary move over there. Grid snapping doesn't matter where you move it because you can always place it back because you snap into the grid. And then what I want to show you is here we have an icon called rounded rectangle. So if I left click on that and I draw out the same box, I think that's 50 by 30, and I move my mouse, you'll see that I've got rounded edges. Now I could click here like this and it'll put fillets on. So if I just move that up here and I press spacebar to get back the last command that I was using, which is nice and quick, so you have to move around a lot. And I can pull that all the way in, and note now I've got a nice pill shape, almost like not the right aspect. A USB-C port is 3mm by 9mm. But here you can see we've got this pill shape now. Okay, so I'm going to move that one over here like that. And then you would notice that if we hover above here, we've got a right mouse option, which is rounded rectangle, conic corners. If we right click that and we draw the same rectangle, and then we move our mouse, you can see here that if I click that, I've got conic corners. So I'm just going to move this one over here, press spacebar, get the last command back. Let's just do one that's a little bit more, and then let's draw over the top just to save some time. Draw one a little, let's draw something a little bit, yeah, in between that. Okay, so I'm going to move that one over here, move that one up here. Alright, now we're going to reorganize these. With this rectangle, what we can do is we can come up here and we can choose fillet corners. And if we choose fillet corners, you'll see it gives us a preview of the radius at all corners. And we can type in here a new dimension like 5mm and then update. So it's a little bit parametric, it's showing us. But once we commit to it, we're locked in. So if I back that out and I type 15, we get a pill shape. Let's back that off. We've got 1mm. Let's do 5mm, not 15mm. Let's do 5mm and press enter. Okay. So we've got our conics and we've got our rectangle. And what we can actually do is get our rectangle back. Let's just draw another rectangle. And we can come up here to adjustable curve blend. And we can click. So it says select the first curve. Now it works on where you click. So let's just click here. Select the second curve. Let's just click over here. And you'll see that it's put in this conic. Now that one's back to front. Don't worry, just flip one. And you can see here we're getting perfect conic G4 at the moment. We could put it on G3. We could have position. If we do position, you'll note we'll get a chamfer, straight line, degree 1, tangency, and curvature, G3 and G4. And you can adjust all of these, and you can add them to different parts of the surface, extrude them, and look at how the highlights work, and make a concerted choice as to the type of geometry. So let's go tangency, go OK, and you'll see it trim that out. So let's go Control Z. Let's get that command back. Adjustable curve blend. Let's click here. Let's click here. Let's flip and turn trim off. So there's the first one, tangency. Let's press spacebar. Let's do another one here and here. I keep getting one the wrong way around. Let's make it curvature. Let's go OK. Do it again. Here, here. Flip one. Make it G3. Go OK. And then let's do the last one. Let's go flip. And let's go G4. Okay. So now that we've got that, I think if I move this, I'm just going to be left with those arcs. So what I'm going to do is I'm just going to trim them, right? So if I go trim, select the cutting objects. So the cutting objects are these curves. Now this is going to be problematic in a few little spots, and we'll see that in a minute. Enter. Let's go trim, trim. Oh, this looks like it's worked. Trim, trim. I was a little bit worried that here I was going to get, no, it's this, I thought I'd have a little bit of a line here. There might have been some kind of error, but there's not. And now let's join that together. So let's select it all. Let's come up here and go join. Alright, so we've got some geometry. This is going to be the wrap up. It's nearly half an hour of talking. So what we're going to do is just organize. I'll leave this one here. Let's get these ones. Let's move them here. Let's get that one. Let's move it there. Let's get this one. Let's move it here. And then let's take these. Let's put them here. That one, we'll put it at the back actually, because it's basically the same as that first one we did. Put that one there. And let's grab this one, put it here. I'm going to delete that actually. Delete. Alright, so let's select them all. Go to our surfacing tools. Come here to extrude straight and let's extrude them up. Now we've extruded them. One of the most important things to understand here is that surface modeling, the surface actually has zero thickness. It has a positive side and it has a negative side. Now, the way to look at this is to come over here to the display icon, click it, make sure you're in shaded here, the display mode shaded, come down to object settings and then click color backfaces. And you can choose your own color here, but typically people use pink. It's because the pink is not used a lot as a selection color for anything in Rhino or in Grasshopper. So here we've got our inside surfaces are pink. Now you might be making something and you'll notice that some surfaces are pink. We can always type the word flip. So if you've got the pink surface, which is the negative side facing out, you can type flip and flip it. It's also an icon up here called flip direction. Okay, and it's important to have the direction of your surfaces going in the right way. Now, what we're going to look at is we're actually going to look at the highlights on the transitions between the surface and the edge. So if I select all these, and I come up here, and I press and hold, and then I choose Zebra Analysis, I can change it from horizontal to vertical. Let's put it in horizontal. I can change the thickness of it. So let's keep it on thinner. And at the moment I'm showing edges as an ISO curves. I can turn it off. But let's turn it on because I think it's important to have a look. So if we come around the back here, here are our rectangles that have had fillets applied. And you'll note that the curvature continuous mode of the fillet actually has a hard edge line. And that's because fillets actually aren't curvature continuous. They're just an arc that's cut off. And if you look at like any design, maybe like a computer box or some kind of engineered object that's got fillets, typically the things that you would make in Fusion 360 or in SolidWorks, and you just add a fillet, or you try to do a variable fillet or some kind of blend fillet. This is the outcome that you're going to get. Now, what we've got here is with our conic curves, you can see how the zebra stripe flows beautifully around the surface. Okay, and we can even see that here on our flat sides, that where we've got a nice curvature continuous, that the flow, the curvature continuity flows really well. Remember here we did a fillet, we did, I think it was curvature tangency here, and you can actually see where it doesn't work as well. Now, when we look at our Apple Watch and we see the ad on TV and they move the Apple Watch around, you see these beautiful highlights. We get seducted by the highlights. It's like a car. You see the highlights on the car. You see beautiful reflections, you know, that show speed and flow and how all the surface panels work together. Well, on your Apple Watch, it's the same kind of thing. That when we turn it around and we look at it in the light, we can see how the light reflections, and here the zebra stripes, flow perfectly over the surface. This is the difference between really good surface modeling and just extruding something and adding fillets in another program, even in Rhino. So good industrial design, we want nice curvature continuous flow, so that our highlights work really well. And you can start to analyze objects that you see around you every day and try and see those effects that I'm talking to you about. There's quite a few objects in our CAD lab that show good curvature continuous surfaces and, you know, very average filleted surface modeling, or solid modeling in that case probably. So that's where we're at. We look forward to seeing you next week in class 2, where we're actually going to start taking some of these surfaces and use Rhino and Grasshopper to put some basic patterns on them. So we're going to start our flex modeling component where we're using Grasshopper to create custom perforation patterns like we saw in the video for the Rolls-Royce seat and door trim panels. Okay, thanks very much, and I look forward to seeing you soon.